force in fluid systems. Alright, the previous activity you already did is looking at the states of matter. But if you didn't, you need to make sure you go back to that so that you can see the features of the 4 different states of matter: solid, liquid, gas. And some people include plasma and some people don't, but we're going to include plasma at this point so that at least you, when you hear it, you have some background to it. Alright, fluids. This is what's kind of unusual. Most people think of a fluid as a liquid, but actually it can also be a gas. There are 2 basic systems when you're talking about fluids. The first one is what is called hydraulic systems. And you can see here the term hydra. Alright. Usually when you are seeing that word, it's going to mean water, alright, but it doesn't have to be water. Hydraulic systems usually contain what they call hydraulic fluid. And here we have a picture, alright, that you have a backhoe. Here you have a dump truck, and they work on hydraulics. Many amusement park rides also work on hydraulics. Okay, pneumatic. Alright, hopefully you just heard that sound. If it is connected to usually a compressor, if you're working in a garage and you have it hooked to an air compressor, it is that air or gas, alright, that is actually moving the drill. Right? We talked about torque before, so that if you had a pneumatic torque wrench, so that you could put the lug nuts onto a tire, alright, and it's set at a certain number of foot-pounds, alright, so that it doesn't go too far. Because if you just were to put that pneumatic, I'm not sure that I would call it a drill, but to put the lug nuts on, you might tighten them too much, and then an ordinary person wouldn't be able to get them off unless you did have something that was pneumatic. Alright, density. The main thing we want to look at here is, you can ignore this here. Density is going to be mass divided by volume. Okay, and an example, if you have 2 silver-looking cubes, they might be exactly the same size, but one is heavier than the other. That would mean that they had a different density. Now, when you're using the density equation, density, remember, is mass divided by volume. Mass is going to be M, volume is going to be V, and density is going to be capital D. So here we have what they call the magic triangle. D equals M divided by V, just like we see it up here. And right here. And if you need help rearranging, what you can do is M is equal to D times V. So that's where we get this from. And then V equals M divided by D, which is where we get that from. So if you need help with rearranging, you can use the magic triangle, as they like to call it. Now, we talked about the variables already. Remember, they are the letters that go into the equations. D for density, M for mass, V for volume. Now, when you're looking at these, you can actually break this up into its parts. When you're looking at density, the thing that is in the numerator, which is the top, alright, that's going to have to be a mass unit. You could have pound mass there in the English. Kilograms for the SI. In the English, you have to have an English unit of measurement, of length, and it needs to be cubed, right, because volume is going to be cubed. Same thing here. You've got the mass is going to be cubed. Alright, so that explains these 2 pieces here. Alright, let's do an example. You want to find the density of an object, and it has a mass of 30 kilograms. Now you might be saying, well, how would we find that? Well, it's given to you in the problem, but what if you did have an object? You would want to use a balance to determine how many kilograms or grams that it contained. And then what about the volume? Well, here again, the volume is given to you. But there are numerous ways that you can find the volume, which we're going to be looking at in a moment. But for right now, let's find the density. We have the density, all right, is equal to the mass, which is right here, divided by the volume. And this is what we get. It's that simple. 30 kilograms divided by 60 cubic meters is going to give you 0.5 kilograms per cubic meter. All right, we were talking about volume before. Volume can be found different ways, depending on what you're looking at. In this case, if you're looking at a rectangular object, the volume is going to be length times width times height. Now that's where the 3 comes in here. All right, because these are all measurements. And when you multiply them together, that's where you get the cube. So that's how you can remember if it's volume. If you were given a listing of things and it had cubic meters, you would know it's volume because of the cube. Later on, we're going to talk about area. Area is just length times width, which would be meters squared. So you see, you've learned something today. You can differentiate between area and volume. All right, a couple other things that you need to know. The density of water is 1. It's 1 gram per cubic centimeter. This is the standard. Another standard that we use is what is called water weight density, all right, which is 62.4 pounds per cubic foot. So that means that if you had a container that was a foot by a foot by a foot, and you filled it with water, it would weigh 62.4 pounds. Okay, that's what that means. Now, where we use this is primarily when we're trying to determine pressure, which is a little bit later on. That's where this really comes in handy. If you have a water tank and you want to figure out what the pressure would be at the valve at the bottom, we use that number. So you're going to want to remember that one. Now the term hydrometer. All right, hydrometer, it's an instrument that measures density. Now, if you were to check to see how much, you're checking your radiator, and you want to see what the density is because it's getting cold, all right, and you want to see how much antifreeze that you have to add. That little thing, it looks like a little eyedropper with a tube on it, that is a hydrometer. They use them for a lot of other things too, hydrometers, to measure the density of different type liquids. But that's pretty much, if you are driving, you should be checking to make sure that you have enough antifreeze in your radiator. That's an instrument that you can buy, all right, at any kind of auto store. And it's an application of this. All right, sometimes we also hear the term specific gravity. All right, specific gravity is density of a substance divided by the density of water. So really what it is, it's a comparison. But it is also a ratio, which means if you're taking the density of one thing and comparing it to the density of water, you're not going to have any unit. So that's a big way that you can tell that it's specific gravity. Here's an example. If you have the density of lead, all right, which is 11.34 grams per cubic centimeter, you divide that by the density of water, which is 1. Well, what happens? The grams per cubic centimeters, they cancel out, and you are left with 11.34. And that's specific gravity, no unit. All right, let's take a look at the table. The variable for each, for specific gravity, it's G, and then an SP afterwards. Density of a substance is capital D with a little s. All right, and density of water is capital D with a W. Look, there is no unit for specific gravity. Here, density of water and density of substance, notice they're going to be the same. It's going to be pound per cubic foot. This is what we're talking about, your mass. You could have pound mass there too, by the way, over something that's cubed. All right, in the SI, you got grams over something that's cubed, a distance that's cubed. That's going to be cubic centimeters. All right, so that's how that works. All right, well, that wraps up talking about density and specific gravity for today. And next time we'll be looking at some other things as well.